Next, I'll be showing you how to solve the ALEKS problem, identify the Bronsted-Lowry acid and base, and draw the product from the proton transfer. So what ALEKS is going to do in this question is it's going to show us a compound and it wants us to kind of visualize the proton transfer reaction that will take place. And then the rules I have for this question is refresh yourself from Chem 2 on acid and bases. Remember that acids are H donors and bases are H acceptors. For those that really kind of need a refreshment or kind of the most common ones that you're going to see in ALEKS, you can feel free to look at this chart right here, or feel free to screenshot it as needed with the acids on the left and the bases on the right. So first we'll start with part one of the question, which is identify the Bronsted-Lowry acid and base. So we see H2SO4, and that's going to be the acid for this question. And if kind of you need verification on this, or as you go through your refresher, you can feel free to always, like I said, refer to this chart. And then we have methyl lithium. And because we've already identified the acid within this question, we're good to just go ahead and assign this as the base. So this isn't a case where it's H2O or anything else where you really were at, well, pretty much H2O can be an acid or a base. So it's not the case for this question. Then we'll go to part two of the question, which is going to ask you to draw the structure of the products for the proton transfer reaction, include lone pair and formal charges on the structure, and then kind of what we want to focus on this part is omit any counter ions. So what that means is pretty much this lithium, once you kind of picture this hydrogen that's going to go over and be donated to this methyl group right here, that you're going to picture that you're not going to have this lithium at the end. So I'll show you how to draw kind of the product or what ALEKS is going to expect. So first we'll start by drawing the upcoming acid for the, or should say the conjugate acid. So hydrogen has moved over to now this methyl group. So we'll draw a C right here. From previous videos, we already know that you have one H that was already there, another H, I should say another hydrogen, one more hydrogen right here. And then now, because the hydrogen was transferred on, you're going to draw one more for it. As you look around, you see that carbon, it satisfies the octet rule, so it doesn't really require no lone pairs. And then you can watch kind of my older videos of how to identify charges, but carbon is neutral. Now, we want to focus on drawing the conjugate base, which is going to be this kind of sulfuric acid, which is now donated this hydrogen over. So we are going to start by drawing the sulfur in the center. We're going to, because it has 4 oxygens on it, we're going to connect it to one oxygen right here. It's going to be double bonded because oxygen like to have two, usually like to have 2 bonds. So we'll start with 1, 2, 3, 4. So 2 lone pairs, and that satisfies the octet rule. We're going to draw one more oxygen on. And it's going to go 1, 2, 3, 4 to satisfy the octet rule. And then up here, we already know that we have another oxygen. And remember that for sulfur, you can really, or for the most part, with it come to this question, you can only have 6 bonds. That's really going to be, around it in this instance. So because you already have your pretty much your 2 double bonds of oxygen here, you're going to, for the third oxygen, it's going to be a single bond. And remember that on this oxygen, you're going to have 1 hydrogen that's going to be attached to it. And so for that to satisfy the octet rule, we're going to go ahead and add 2 more lone pairs on that. And then last, we're going to focus on the oxygen that donated its hydrogen away to CH3. So we're going to draw this oxygen here. And Because that hydrogen is now away to satisfy the octet rule, we see it already has 2, but we're going to write 3 more lone pairs. So that way it has 8, so it satisfied the octet rule. And then what we want to do is, because this oxygen has donated its hydrogen away, we're going to do a charge check on it. So going back to the periodic table, we remember that oxygen is in group 6 alpha. So we're going to start with the number 6. We're going to count the electrons and the bonds around it. So 1, 2, 3, 4, 5, 6, 7. We're going to subtract 7 right here from it. And that's going to equal -1. So right here where this oxygen is, we're going to ensure that we put the negative charge for it. And this is pretty much going to be your products for it. As mentioned before, just remember the rules of this question. Omit the counter ions. So if you have like sodium or lithium or somewhere in there and it's attached to a methyl or whatnot, you won't include that when drawing the products. Hope this helps. As always, if you have any questions, feel free to reach out, but like, share, and subscribe. Thank you.